So the key to problem number 3 is the fact that, okay, Joan's doing the race, yada, 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 and it is saying assuming a normal distribution. So just in case you've had a little bit of a hard time understanding what they mean by normal distribution in the textbook, I'm going to give you a real basic crash course. So normal, assuming I could draw, would be a little something akin to this. This is called the normal curve. So the mean, or the average, if everything is normal, means that you'd have more people that are here in the middle, right? Then you would have a smaller number of people who are, faster. Then you would have an even smaller number of people than that are a lot faster. And then you would have an even smaller number of people than that who are even faster than that. Same deal. So basically, these are the people to the right here that are above average, and it works the same on the left hand side. So assuming, again, this is your mean, then you've got your people that are just a little bit slower than average. Then you've got a slightly smaller group that is even slower than that. And then you've got a really tiny group that, God bless them for being in the race, but they are slow, right? Because they're over here to the left, so you're slower over there. So Joan has run this race, and her race was 1.75 standard deviations faster than the women's average. Now, what that would sometimes make people inclined to think is, oh, well, she's fast. That's good. That means that, if she's 1.75 standard deviations faster, that's pretty darn faster than average. So you would think, okay, so that means that Joan is over here somewhere, right, with the fast people. But of course, the way a race works, it's better if you take a shorter amount of time. So that means that Joan is actually, because we're talking about her actual, the time it took her to finish the race, because it's talking about her time. So that means that Joan is over here on the, here's Joan, on the lower end of average. So we've got to figure out if she's 1.75 standard deviations faster, so 1.75 standard deviations less than her age group, how many were faster than Joan? So let's think about what that means. So here's Joan. So we want to know who is even faster than Joan. So that means who took even less time than she did. So we're looking for these like really super fast folks, that are over here to the left of Joan. And again, I'm not saying my picture is trying to scale or anything like that, just giving you like the general idea. So we need to figure out what we basically need to figure out what's called finding the area of the curve. We need to figure out how many people are here in this part of the curve below 1.75. So who is to the left or below 175? Like what percent that is. And you happen to have a handy dandy little chart in your textbook that tells you that. So that chart can be found here in Appendix C, page 773. And what this chart tells you is the normal area below, to the left of that particular z-score. So what do I mean by that? So first of all, Joan was already below the average, right? Because here's the average here in the middle, and she was below the average. So when you're below average and you have your 1.75 standard deviations, that's what we call a negative z-score. And we call it a negative z-score because her z-score was 1.75 standard deviations below. So the z-score I'm going to look for in that chart is negative 1.75. So I'm going to the part of that chart that is in the negative. So the first page, see the first page here, the z-scores, and I know, serious computer lag. Let me undim that. So the z-scores here on this first page are positive z-scores. That's not what we want because she's below the average. So we are looking for a negative z-score. So we are going to go to the table in Appendix C that has all the negative z-scores. So that's actually page 774, I believe. And because we are looking for, now the way this thing is organized can be kind of confusing to people, and I really wish it would let you zoom in a little bit, but that's okay. So we're looking for negative 1.75. So we need to look down here on the left, and first of all, notice there's only a number in front of the decimal and then a number behind the decimal. So we first have to find the part of the chart that says 1.7, and then we need to go over to the row, so this part here, that has the 5 because it's 1.75. So I'm going to scroll down to negative 1.7. Okay, so here's my negative 1.7. Oops. And then this would be, I know the thing I don't like about this chart too is it kind of cuts off the top, but this is 0.00, 0.01, 0.02, 0.03, 0.04, 0.05. I don't know if on your view, if it kind of cuts off the top so that you can't see or not, but on mine it does. And my stylus is doing crazy things, and it's not wanting to write, doggone it. And this is the part we're like really interested in. So hang on one sec. So I think I got my tech issue sorted out. So again, we're looking for negative 1.75. So that is why we looked for negative 1.7 over here on the left. And then we counted over, 0, 1, 2, 3, 4, and 5 because it's kind of cut off. And so where do those 2 points intersect? So if we go down this column and we go across to this row, they intersect right here at 0.0401. So that is the value from the table that we need, so 0.0401. So think about what that 0.0401 represents, okay? So remember, here's our average runner. Our runner, forgot her name, but she's somewhere below average because she was fast. We're trying to figure out the people that were even faster than her, so the people that are right here. So that was obviously not very many, right? 0.0401. So as a percentage, that's 4.01%. So that's not very many people, okay, that were faster than she was. So how do we figure out, that's the percent, but that's not what the question is asking us for. The question is asking us, how many women does that translate to? How many women were actually faster? So in order to figure that out, we know that we had 405 women, and then we multiply that by that 0.0401 to figure out how many women that would be. And I've done the calculations already. So that would be, if I multiplied that together, that would be 16.2405, which obviously rounds to just 16 women. So there were only 16 women who were faster than Joan.